Hey, I know for a lot of you, math seems to be more and more complicated and messy. The problem you're looking at right now, we're looking at together, is no exception. But math, especially algebra, is really about making the complicated into the simple, right? It's taking something messy and turning it into something neat and easy to understand. And today we're going to experience that together with the practice problem. So get ready to take this complicated math, and we'll use the product powers rule and the quotient of powers rule, and a couple of fancy ones, and we're going to make it simple. Okay? So first, when you see a problem like this, you need to kind of have a strategy how you're going to solve it. Now, what I'm going to do, looking at this, is I want to first take this entire side and deal with this first. And then after that, I'll deal with this other side second. Okay? And I know, let me write myself, they're multiplied by one another. So let's start with the first side. And I'm going to take this y squared plus y squared term. I want to solve that right off the bat because inside it's addition, but it's inside the grouping symbols. So let's see. I have 1y squared, and you come along and hand me another y squared. So I've got 1y squared in each of my hands. So I've got two hands. Y squared plus y squared just equals 2y squared. Put that in parentheses. And then we've got that's times 3x squared and the fourth. And that's all over 3x z to the minus 3 and 2y squared. 2y squared, that sounds familiar. Wait, there's a 2y up here. And there's a 2y squared down here. So 2y squared divided by 2y squared is just a fancy one, so I can make those ones. Wait a minute, I see another one here. 3 in the top, I'm sorry. Keep that 3 there. We're going to get that 3, cross that out there, and make that a 1. And we got another fancy one. All right, so let's see what we have left here. We have x squared right here, so we'll say x squared times z to the fourth. And that over, and then one x down here, and that's times z to the minus third. Cool. So now I can use the quotient of powers rule. The quotient of powers rule tells me that it's just going to be x to the 2 minus 1 power. And this is going to be z to the 4 minus 3 power. Right? So that'll be easy. Oh, wait, I see some hands up. I think I did that wrong. Okay, a minute, let's look at it again. Oh, yeah, so that's, it's got to be z, since we're shifting, it's z minus 3. Z fourth minus 3. So that's going to be different. I was going to come out with first, but it should be, let's do that math. This becomes x to the first, and this becomes z to the 7th. Thank you for catching that mistake before I made it. And that's about as simple as we're going to make everything on this side. So let's go and take on this side. Okay, the thing I see that I deal with is I want to deal with this 2x, the whole quantity to the third power. And I need to remember there, I was going to draw this. I need to distribute the third power both to the 2 and y, not just to the y. All right, so this is x to the 5th. We've got that. We've got 2 to the third power times y to the third power times z to the negative 7th power. All right. And now all over 8x to the 6th power, y to the 3rd power. All right. So let me get a couple of quick things out of here. This 2/3 power, 2 to the 1st power is 2, 2nd power 4, 2 to the 3rd is 8. So just replace that with an here. Wait a minute, I see an 8 above and below the division bar, so that's just a fancy one. I also see y to the 3rd above and below. That becomes another fancy one. So let's see what I have left. I've got x to the 5th divided by the using quotient of powers rules, x to the 5 minus 6, and z to the negative 7th, just keep z to the negative 7th. That's all we got left on the side. So that becomes, we'll take down here so we're mirroring this other. This becomes x negative 1 and d times c to the negative 7. Now, two different ways we can solve this, and we're going to do it both ways. The first is I'm going to use quotient of powers rule. Using the quotient of powers rule in groups is going to be, I'm sorry, the product of power rule. So this is going to be x to the 1st times x to the minus 1st. So this becomes x to the 1 plus or minus 1, and that is x to the 1 minus 1 power. And z becomes z to the 7 plus or minus 7 power. And that just becomes times z to the 7 power. All right. If I do that, I have x to the 0 power times z to the 0 power, and I'm not quite sure what to do with that. So let's try a little different on this side. Here we're going to say we're going to change around x to the negative 1 power into 1 over x to the 1st. And we're going to change z to the negative 7th power into 1 over e to the 7th power. And we're going to multiply that by this equation over here, or this expression over here, which is to the power times z to the 7th power. Why put a second in there? I meant 7th. All right. Then we'll put these together. What? Combining like terms, we end up with x to the power 1 over x to the 1st power, and that just becomes that. We multiply that by take 2 and this term. So it's z to the 7 over 9, 1 over z to the 7th. So that's just z to the 7th over z to the 7th. So anything divided by itself equals 1. This is just 1 times. Same thing here. So that's 1 equals 1. So take that equation, bring that back over this side. That makes to 0 power 1. And z to the 0 power is also 1. And that over, remind ourselves, any number to the 0 power equals 1. All right, so let's go all the way back. And we took this whole mess here and we simplified to just that as the answer. All right, good luck with the problem.